Alright guys, welcome to standard form of quadratic functions. Okay, so we've already talked about vertex form, and so the standard form of a quadratic function is this: f of x equals ax squared plus bx plus c. A cannot be 0 because a is the quadratic part, bx is the linear part, and c would be the constant part. So if a is 0, we've lost our quadratic part. We get most could have a linear equation there. So this video is going to focus on just kind of the properties and identifying certain things about the equation, which would lead us into graphing quadratic functions, which is our second video. So we're going to focus on what this equation tells us. So a, b, and c, those values provide key information about the graph. So such as down here, if you look, the y-intercept is 0c. That's a major feature. So this equation off the top of our right off the bat can tell us the y-intercept. So standard form is different than vertex form. It doesn't tell you the vertex at first, but it still has some key features, and that's what we're going to focus on. So some properties of quadratics in standard form. If a is greater than 0, the parabola opens up and the vertex is a minimum value. If a is less than 0, the parabola will open down and the vertex is going to be a maximum value. Now, the axis of symmetry can be defined, but it's not as easy as it was with vertex form where it was x equals h. The axis of symmetry here is defined by the equation x equals negative b over 2a. Well, the vertex then is f of that value, because remember, the vertex now is going to be negative b over that 2a, because remember, the vertex value matches the axis of symmetry, so those are the same, and then you would have that f of negative b over 2a. So if you plug that answer, negative b over 2a, into your function, you're going to be able to find the y-coordinate of the vertex. And we know I already talked about the y-intercept is 0c. And so we're going to be looking at these properties of quadratics and be able to find different things. So let's go ahead and look at our first example. So the first example is asking us, what is the vertex form of the standard form equation y equals 2x squared plus 10x plus 7? Okay, so if I'm going to rewrite this equation, okay, so let's just go ahead and write y equals 2x squared plus 10x equals, or plus 7. Okay, so number one, if I want vertex form, I got to find the vertex. So my first step is the vertex. Now, the vertex value matches the x equals negative b over 2a. So basically, if I find the axis of symmetry, I can find the x-coordinate of my vertex. So let's go ahead and substitute. So we have negative b, which is 10. B is our value is our 10, divided by 2 times a. Our a value is 2. So if you want to quickly go ahead, you can say up here, if you're identifying your values, a is 2, b is 10, and c is 7. So now I have all my values right there. Okay, so I go ahead and simplify this. I get negative 10 over 4, which is negative 2.5. Now I'm going to put that in decimal form because I have to find the y-coordinate. So here's my x-coordinate. Now the y-coordinate is y equals 2 times the quantity. Well, guess what we're going to be substituting in now? We're going to be substituting what we found for x, and that's going to give us the y-coordinate of our vertex. So now negative 2.5 gets plugged in for x. So I go ahead and plug that in, and when I simplify that, I get negative 5.5. Step number 2, now that I have my vertex, so the vertex here is negative 2.5, comma, negative 5.5. There's my vertex. So I've got that. I'll just box that so I know there's my vertex. Step 2, we're going to write the equation. Now the equation is vertex form. Okay, that's what they asked us. So what's really nice about this, if I go ahead and write y equals a times the quantity x minus h squared plus k. I've got all three of these values. Look, here's h, here's k, and look, we already have a. That's a great thing. That's a nice thing. So just substitute. So we're going to have y equals, our a value is 2, x plus 2.5 squared, right, on the outside, 2.5, that quantity squared, minus 5.5. And that is my vertex form. So any standard form equation can be written in vertex form. Now let's go ahead and look at another example. Whoops. Here we go. What is the vertex form of y equals, so this one's a little more challenging, y equals negative x squared minus 8x plus 3. Now, one thing I'm going to go ahead and do, first thing, I'm going to just go ahead and change this addition to subtraction to addition, so plus a negative. Okay, so let's look at a, b, and c. Our a value is negative 1. Our b value is negative 8. Our c value is 3. So again, find the vertex form. Let's find our vertex. We have x equals negative b over 2a. So now I've identified a, b, and c. Now let's plug them in. Negative, our b value is negative 8. So that's why I changed that to plus a negative. I didn't want to miss this opposite. A lot of times that negative, people correspond this negative with this one, and that's not the case. 2 over, that should be negative 1, right? So I get negative 8 over negative 2, which is, or sorry, 8 over negative 2, which is negative 4. Okay, so now I have to find my y value. Y equals negative. Now I'm going to keep the negative on the outside, and I'll tell you where another spot you can mess up, and that's okay, but we'll fix it. Negative 4 plus 3. Whoops. The other spot people mess up on is right here. They miss the negative, okay? Or they put the negative to the number first before they square it. You have to square it first. This negative on the outside is like multiplying by negative 1, so you really have the opposite of 16, which is negative 4 squared, plus 32 plus 3, which I believe gives us 19. So now we write our equation. We have our a, so y equals, our a value is negative 1, so negative x plus 4 squared plus 19. Remember that the vertex here was negative 4, 19 if I wrote that in. So I have my h and k. H and k, and my a value was right there. Alright guys, so that is the vertex form, how to write in vertex form from standard form. So let's look at another example. Now here is the pieces where you can go ahead and identify the vertex, axis of symmetry, the maximum or the minimum value and range of the function. Now the function we're going to be looking at is y equals negative x squared plus 2x plus 1. So again, now what we're going to do is if we can identify the vertex, axis of symmetry, it's a maximum, min, or the range, really we can graph these functions. Basically, if we know the vertex and the axis of symmetry, this can help us out to graph standard form. Okay, so number one, they want the vertex. Well, I can start with the vertex, but if I get the axis of symmetry, I get half of the vertex. So axis of symmetry. Okay, so we're going to go ahead and find the axis of symmetry. It's x equals the opposite of my b value, which is 2, all over 2 times a, which is negative 1. So this is negative 2 over negative 2, which is 1. Okay, so that is my axis of symmetry, negative 2 over negative 2, which is 1. So now if I want my y value, it becomes y equals the opposite of 1 squared plus 2 times 1 plus 1. So let's see. 1 squared is 1, so it's negative 1 plus 2 plus 1. So I get 2. Okay, so Now I know that's the axis of symmetry is here. The vertex is 1, 2. Now we need to know whether this is a maximum or minimum. So the parabola, so A is, so I guess let's just make a 1, 2. We'll start this as our third part. A is less than 0, so this implies our parabola opens down. So the vertex is a maximum. So we have to find the maximum. Maximum, okay, so we got to find the maximum. So the maximum here is going to be y equals 2. Okay, the maximum or minimum value is that y value right there for parabolas. Okay, so now the range is pretty easy. The range of y, so y is our maximum value. Our maximum value is 2. We can include 2. All real numbers are in the domain, and we go to negative infinity because this opens down. Okay, so that's how we identify the vertex axis of symmetry of our function. Okay, and so that's going to really do it for the standard form of quadratic functions. Now, I didn't focus on any graphing here. I focused on some of these key ideas, identifying the vertex axis of symmetry, max and min, because those all can be used to graph. Okay, so in the next video, you're going to see a concentration on graphing. So if you guys have any questions or comments, just go ahead and email me, and we'll see you next time.